What if reality is not random? Part of the Thinking Library. The What If series, Volume 4. Introduction. What if reality is not random? Look around you for a moment. Not just casually, but deliberately. The rhythm of your breathing. The steady pull of gravity holding you in place. The way light travels from the sun, across millions of kilometers, and arrives here with perfect consistency every single day. Nothing hesitates. Nothing forgets what it is supposed to do. Now here's the question that quietly sits beneath all of it. What if this is not an accident? We are often told that reality is the product of randomness. That everything, from galaxies to human consciousness, is the result of blind processes unfolding over time. No intention, no direction, just probability playing out across an unimaginable scale. And at first glance, that explanation feels sufficient. But then you start noticing things. Patterns, structures, repetitions that don't just occur, but persist. You see spirals in galaxies that mirror the curves of seashells. You see branching systems in rivers that resemble the veins in your body. You see mathematical relationships appearing in places that have no reason to know mathematics at all. And suddenly, randomness begins to feel organized. Not chaotic, but constrained. Not arbitrary, but consistent. It's as if the universe is following rules. Not loose tendencies, but precise, unwavering laws. Gravity does not occasionally forget how to work. The speed of light does not fluctuate depending on mood or circumstance. The constants that govern reality remain fixed, as though they were set, carefully, intentionally, and once. Which brings us to a deeper, more unsettling thought. Why are there laws at all? Why does reality behave in a predictable way, instead of dissolving into disorder? Because if everything were truly random, you wouldn't expect stability. You wouldn't expect repeatable patterns. You certainly wouldn't expect a universe that can be understood, measured, predicted, with equations that work not just here, but everywhere we look. And yet, that is exactly what we find. A universe that is not only structured, but intelligible. A universe that can be described in the language of mathematics, as if it were written in it. So now the question sharpens. What if the laws of physics are not just descriptions of reality, but instructions? What if they are not simply observed, but established? And what if the patterns we see, fractals, proportions, symmetries, are not coincidences, but signatures, signs of something deeper beneath the surface? Because if there is intention behind the laws, even at the most fundamental level, then reality is not just happening, it is unfolding. And if that is true, then everything changes. The way we understand existence, the way we understand ourselves, even the way we define meaning. Because in a random universe, meaning is something we invent. But in a structured one, meaning might be something we discover. So this is where we begin. Not with answers, but with a possibility. A quiet but powerful shift in perspective. What if the universe is not the result of chance, but the expression of something that chose order over chaos? What if reality, at its core, was never random at all? Chapter 1. The Illusion of Chaos. At first glance, the universe feels unpredictable. Storms gather without warning. Markets rise and fall. Lives intersect in ways that seem unplanned, almost accidental. If you zoom in on any single moment, it looks messy, events colliding, overlapping, unfolding without clear direction. It's easy, then, to assume that randomness sits at the foundation of everything. But that assumption begins to loosen the moment you step back. Because what appears chaotic up close often reveals structure from a distance. Take weather. A gust of wind feels random, almost directionless. But when scientists observe atmospheric systems over time, patterns emerge, cycles of pressure, temperature, and motion that follow consistent rules. The same is true for ocean currents, ecosystems, even patterns in human behavior when viewed across large populations. What looks like disorder starts to behave like a system. This is where chaos theory enters the conversation. It explores how systems can appear wildly unpredictable while still being governed by precise underlying laws. Small differences in starting conditions can lead to very different outcomes, but the system itself is not random. It is sensitive, not lawless. A well-known illustration is the butterfly effect, the idea that a small disturbance, like a butterfly flapping its wings, could influence weather patterns much later. Not because the system lacks order, but because it is deeply interconnected. And that changes how we think about uncertainty. Because if chaos is structured beneath the surface, then randomness may not be as fundamental as it seems. Now take this a step further. Even at the microscopic level, where quantum physics introduces probability and uncertainty, there are still boundaries. Outcomes may not be predictable with certainty, but they are constrained within mathematical frameworks. Possibilities exist within limits. So even unpredictability follows rules. This leads to a quiet but important realization. What we call random may simply be what we cannot yet predict. Not because it lacks order, but because the order is too complex for us to fully grasp. And if that's the case, then the universe is not built on chaos. It is layered with it. A surface turbulence covering a deeper consistency, like waves on the ocean, restless and irregular, yet governed by tides, gravity, and planetary motion beneath. So the question begins to change. Not, why is everything random? But, why does everything appear random when it is not? Why does reality allow unpredictability on the surface, while maintaining such stability underneath? Is it a limitation of perception? Or is there something more deliberate at play? A system balancing structure and variation? Because a completely rigid universe would leave no room for change, no emergence, no life. But a completely chaotic one would offer no stability, no patterns, no meaning. And yet, what we observe is something in between. A universe that moves, adapts, evolves, but does not collapse into disorder. Structured, but not static. Dynamic, but not lawless. So perhaps the real illusion is not that the universe is chaotic. Perhaps the illusion is that we've mistaken complexity for randomness. And if that's true, then what we're witnessing is not disorder at all. It's a system we are only beginning to understand. Chapter 2. The patterns that shouldn't exist. If chaos is only the surface, then patterns are the cracks where something deeper shows through. And once you start noticing them, they become impossible to ignore. Not because they are rare, but because they are everywhere. Look closely at nature, and you begin to see repetition across completely different scales of existence. A fern leaf mirrors the shape of its smaller leaves. Rivers branch like veins. Lightning splits through the sky in patterns that resemble tree roots. These are not just visual similarities. They follow mathematical rules known as fractals. Through fractal geometry, we discover that complexity can emerge from simple equations repeated over and over again. But here's what's strange. Why does the universe favor this kind of recursive design? Why reuse the same structure across biology, geology, and even cosmic formations? It begins to feel less like coincidence and more like a signature. Then there's the golden ratio, approximately 1.618, a number that keeps appearing in systems that are efficient, stable, or visually harmonious. You'll find it in the spiral of a nautilus shell, the arrangement of sunflower seeds, the proportions of certain human features, the structure of storms and galaxies. It's not present everywhere, but where it appears, it often corresponds with optimization. Growth patterns that maximize space. Structures that distribute energy efficiently. So again, the question returns. Why this number? Out of infinite possible ratios, why does reality seem to lean toward specific ones? There's also symmetry, another recurring theme. Snowflakes form with near-perfect geometric balance. Crystals align in repeating lattices. Even the laws of physics themselves are built on symmetrical principles, where certain properties remain unchanged under transformation. Physicists rely on these symmetries because they aren't just aesthetic, they're predictive. They reveal what must remain constant. And that's where things get interesting. Because symmetry suggests constraint. It implies that not everything is allowed, that there are boundaries shaping how reality can unfold. Individually, each of these patterns might be explained away. Fractals emerge from iterative processes. The golden ratio appears in growth optimization. Symmetry arises from physical constraints, but together they tell a larger story, a story of consistency, a story of preference, a story of a universe that doesn't just allow patterns, but seems to favor them. And that's where the tension builds. Because patterns are not just repetition, they are compression. They are the universe doing more with less. Simple rules, repeated, generating complexity that feels almost intentional. So we're left with a difficult question to ignore. Are these patterns simply the byproduct of natural processes? Or are natural processes themselves shaped by something deeper, something that selects which patterns are possible? Because if the same mathematical ideas keep appearing across completely unrelated systems, then maybe mathematics is not just a tool we use to describe reality. Maybe it's the framework reality is built on. And if that's true, then every spiral, every branch, every symmetry is not just a coincidence. It's a clue. A glimpse into an underlying structure that is consistent, efficient, and strangely familiar. As if the universe isn't just forming patterns, but following them. Chapter 3. The Laws That Never Break. If patterns suggest structure, then laws confirm it. Because beneath everything we observe, every motion, every interaction, every transformation, there are rules that do not change. Not occasionally, not approximately, always. Gravity does not weaken without reason. Light does not change speed depending on where it travels. The same principles that govern a falling object on Earth also govern the motion of planets and the behavior of distant galaxies. This consistency is not just useful, it is foundational. It means the universe is stable, not predictable in every detail, but reliable at its core. The rules hold, regardless of time or place. What works here works everywhere we can observe. We call these rules the laws of physics. But that term can be misleading, because laws are not physical objects. You cannot point to one or hold it in your hand. They are descriptions, mathematical relationships that consistently match how reality behaves. Which leads to an important question. Are these laws something we discovered, or something that exists independently of us? Again and again, mathematics developed in abstraction ends up describing the real world with astonishing accuracy. Equations written without any reference to physical reality later prove to match it precisely. It's as if the universe already operates in a language we are only beginning to understand. This raises a deeper tension. Because if the laws of physics are simply descriptions, why do they work so perfectly? Why does reality follow consistent, precise rules at all? And more importantly, why don't those rules ever break? Across all observations, the fundamental constants of nature remain fixed. The speed of light does not drift. The strength of gravity does not fluctuate. The charge of an electron does not vary from place to place. These are not flexible tendencies. They are absolute. In a truly random system, you might expect variation. You might expect irregularities or breakdowns in behavior. But what we find instead is consistency across time and space. A universe that behaves the same way today as it did billions of years ago. So the question deepens. Why is there order at all? Why does reality follow rules instead of dissolving into unpredictability? One possibility is that this is simply the nature of existence. No further explanation required. But another possibility begins to take shape. That these laws are not just observations, but constraints. not just patterns we notice, but boundaries that define what is possible. Because laws do more than describe reality. They limit it. They determine what can happen and what cannot. And if that's true, then the universe is not just unfolding freely. It is operating within a framework, a structure that governs its behavior at every level. So the question becomes harder to ignore. Did we uncover these laws? Or are we revealing something that was already set in place? Because if the laws of physics are universal, fixed, and unchanging, then they begin to look less like coincidences and more like foundations. Chapter 4. The Universe Dialed In. If the laws of physics are fixed, then another question emerges. Why these laws, and why these values? Because laws alone are not enough to define a universe. Their specific settings, the constants, determine how reality unfolds. The strength of gravity, the mass of particles, the rate of cosmic expansion. These are not vague qualities. They are precise values. And if you change them, even slightly, the universe as we know it would not exist. This idea is known as fine-tuning. It suggests that the conditions allowing complexity and ultimately life exist within extremely narrow limits. Consider gravity. If it were slightly stronger, matter would collapse too quickly. Stars would burn rapidly and disappear before planets could form. If it were weaker, matter would never gather at all. No stars, no galaxies. Now consider the expansion of the universe. If it had expanded just a bit faster after its origin, matter would spread too thinly for structure to form. A bit slower, and the universe could collapse back in on itself before anything complex could emerge. These margins are not broad. They are incredibly tight. Small deviations would result in a universe that is empty, unstable, or short-lived, which leads to a striking realization. The universe does not just allow structure. It allows it under very specific conditions. So how do we explain this? One possibility is chance. If there are countless universes, each with different parameters, then it is not surprising that at least one would support complexity. We exist in that one because we can. Another possibility is necessity. Perhaps these values could not have been different. Maybe there is a deeper theory, still undiscovered, that explains why the constants must be what they are. But there is a third possibility, that the universe is not just compatible with life, but configured in a way that makes life possible, not necessarily through intention as we usually define it, but through selection from a range of possibilities. Because fine-tuning highlights something deeper. It is not just about how the universe behaves. It is about how it could have behaved, but doesn't. Out of what appears to be a vast range of alternatives, reality exists in a narrow band where structure and complexity are possible. And that narrowness is difficult to ignore. Because if everything could have been otherwise, why wasn't it? Why these values? Why a universe that is stable enough to form stars, complex enough to form chemistry, and precise enough to allow awareness? At this point, randomness begins to feel incomplete as an explanation. Not necessarily wrong, but insufficient on its own. Because we are not just observing a universe that works. We are observing one that works within exact limits. And whether that precision comes from chance, necessity, or something more, it points to a reality that is not arbitrary, but constrained, and possibly calibrated. Chapter 5. Intelligence or Illusion. By now, the pattern is unmistakable. The universe follows laws that do not change. It operates within narrow conditions that allow structure to exist. And within those conditions, patterns emerge again and again. So the question becomes unavoidable. Is this the result of intelligence, or the illusion of it? Because recognizing order is one thing. Assigning intention to it is another. Humans are natural pattern seekers. We connect dots, find meaning, and interpret structure, even when the underlying cause may be purely mechanical. So one possibility is this. Everything we've explored is real, but our interpretation is not. The laws, the patterns, the fine-tuning, all of it may arise naturally from underlying processes without any guiding intelligence. In this view, the appearance of design is simply a byproduct of complexity unfolding under consistent rules. There is even a framework that supports this perspective, the anthropic principle. It suggests that we observe a universe compatible with life because only such a universe can be observed. In other words, there is no need for design, only selection. But this explanation has limits. It tells us why we can observe the universe, but not why the universe has the properties that allow observation in the first place. It addresses perspective, but not origin. So the alternative remains that the structure we see reflects something deeper, not necessarily a conscious designer, but perhaps a form of intelligence embedded within reality itself. Some philosophical perspectives explore this through panpsychism, the idea that consciousness, or something like it, is a fundamental aspect of the universe. In that view, awareness is not something that emerges late. It is part of the foundation. And if that's true, then the order we observe is not imposed externally. It arises from within. But here's the challenge. Both explanations can account for what we see. A structured universe can emerge from blind processes, and a structured universe can reflect intentional design. From the outside, they may look identical. So how do we tell the difference? That is the question without a clear answer, because we are not outside observers. We are inside the system we are trying to understand. Our conclusions are shaped not only by evidence, but by interpretation. By whether we see order as something that happens, or something that is meant. And perhaps that is the point. Because whether the universe is guided by intelligence or shaped by impersonal laws, it is not random in the way we once imagined. It is structured, consistent, coherent, and filled with patterns that invite meaning. So the final question turns inward. When we see order in reality, are we discovering something that exists, or revealing something about how we see? Because the line between intelligence and illusion may not lie in the universe itself, but in the observer. Conclusion: what if we're meant to ask? We began with a question. What if reality is not random? And what started as a possibility became something more. We examined chaos and found structure beneath it. We followed patterns and saw them repeat across scales. We explored laws that never break. We confronted a universe balanced within narrow limits. And we reached a point where interpretation becomes unavoidable, not with answers, but with clarity about the mystery. Because what emerges from all of this is not proof of design, nor proof of pure chance. It is something more fundamental. Reality is coherent. It behaves in ways that are consistent, structured, and deeply interconnected. It is not a collection of unrelated events. It is a system, and that alone is remarkable, because it means the universe does not resist understanding. It allows it. The laws hold. The patterns repeat. Mathematics describes reality with precision. And within that structure, something unexpected appears. Awareness. Not just existence, but the ability to observe it, to question it, to search for meaning within it. That may be the most extraordinary part of all, because the universe does not need observers to exist. It could unfold silently, without reflection, without awareness. And yet, it produces minds capable of asking why. So perhaps the question shifts again. Not whether reality is designed or random, but why it gives rise to beings who can ask that question at all. Because even in a purely natural framework, this is not trivial. Awareness is not required for matter to behave according to laws. And yet, here it is, which suggests another possibility, that the ability to question reality is not separate from it, but part of it, not an accident, but a continuation, a system becoming aware of itself. And from that perspective, the search for meaning takes on a different shape. It is no longer something imposed from the outside. It becomes something uncovered from within. So the final question is not, is there meaning? But, is meaning something we create, or something we discover? That is not something this series resolves. But it may be the right question to carry forward. Because whether reality is shaped by intelligence, necessity, or chance, you are here, within it, able to ask. And that fact alone is difficult to dismiss, not as proof, but as significance. Because if reality is not random, then the questions we ask are not trivial. They are part of the structure, part of the unfolding. So this is not an ending. It is an invitation to keep exploring, to keep questioning, to keep looking for patterns, laws, and meaning in everything around you. Because if reality is not random, then every question you ask belongs to the answer,